Hello everyone, this is KP the Math G. It's early in January morning, and I'm very delighted to be able to discuss calculus early in the morning. And it's kind of early because my wife is still, I don't know if she's sleeping, but if she is not sleeping, she's still in bed sitting up looking at her phone. She checks phone messages or uh, uh, she has a prayer list, and sometimes she does that. She prays over those individuals who are on that list. So anyway, putting everything aside, um, this is just something that I like to do. Is I like to spend time with her, but when I can get away and have a little time for doing this, this is what I like to do. I love calculus. All right, we're looking at the first fundamental theorem of the calculus. And doesn't that sound in and of itself just sound really good? The first fundamental theorem of the calculus. And here it is. What does this mean right here? This is d over dx. That means the derivative. This is kind of the antiderivative. A is a number. Alright. It is just, all you're doing is plugging x into this t right here, and you have f at x. Now, why do you not have minus f at a? Well, it's simple, because f at a is a number and the derivative of a constant is 0, so all you're left with is f of that variable. Now we really want to say add a little extra to that, times the derivative of that variable, but the derivative of x is just 1, so it's just f at x times 1, which is just f at x. Okay, we kind of ignore, I like to say we don't really ignore it, because, well, we do, simply because the derivative of a constant is 0, so we just take the variable and then take the derivative of what's inside here. Alright, so that's going to be important that we understand that throughout the lesson. Okay, sometimes it doesn't have the d, it just does not have that. So what instead, let me erase this, bear with me please, I'm sorry. Okay, instead what it'll have is the derivative. You'll see this with the prime sign right there, or maybe just the prime sign is here, but that still means the derivative of the definite integral. Okay, anytime you have that, you just get that back. Alright, so let's just start with something that is, I'm going to erase this rule because I need room. I'm going to need all the room I can muster today. Alright, there we go. Alright, so tell you what, we're going to probably change colors here in a little bit, but let's take, for example, dx. Alright, so that's the derivative of something. Alright, so that's the derivative of, now remember, that's a number. Pi over 2 is a number, so we're going to ignore that part of it. But there's the x. And of course, it's got to be a different letter here. Okay. And that's just simply, all you're doing is plugging this in. Don't take the derivative, the antiderivative sign, and get negative cosine, because you got to take the derivative of that again. You come back to sine, and it just comes right back to where it was. Alright, so sine of x, and that's it. The derivative of x is 1, So just sine of x. That's a very simple one, isn't it? Alright. Now here's one that's a little bit different than the other. D over dx, and this time I'm going to take the integral from 0 to x cubed. Alright, this is a little different here. Tangent of t dt. Now please be careful here. One thing I want to say before we start going any further, this is pointed out in the AP calculus classes quite a bit. But actually it could be in a regular calculus class. I know when I took a regular calculus class, I did not, yes I did, but we didn't see a whole lot of it. And I think you see a lot more of this now in the AP class, and you may see a little bit in a regular calculus class. I just wanted to bear that out. So that's why we're covering this at this time. The one that we really want to be concerned about more, I say more, this is important, but we use the other one more. This is then that's the second fundamental theorem of the calculus. So we actually have two fundamental theorems of the calculus. This is the first one, and then you have the second one, which you're going to use quite frequently. Alright, so anyway, alright, so this is our problem, and again it's just tangent. Alright, so x cubed. Now the thing about it is we have to take the derivative of x cubed. Okay, so now that's a little, this was the same here. The derivative of x is just 1. So if you wanted to do that, but that's still equal to sine x. Okay, so I did the same thing. I just left off the derivative of x, which is 1. This here is, I'm just taking the derivative of this, and you know this derivative. It's this 3x squared. Alright, so tangent x cubed. Do not multiply these two together. This is called the argument. This is just a term that's outside the argument, and you don't put this inside that. Put it in front maybe. Alright, so this equals to 3x squared tangent x cubed. Whether this is in parentheses or not, it's okay, but that is the final answer to this. So again, just remember, you're taking the derivative of what's inside here. You're putting this inside here, and you're taking the derivative of it. Now let's get to one that's a little bit more to it, and I think I'm going to let this be my last example. It's a good one. It's a doozy. So matter of fact, I'm probably let's see, let's just flip the board over. Okay, let's just flip it. Well, okay, you want to go that way. Alright, here, come on, eraser. Okay, bear with me, everyone. Alright, let's move it back. This one's a good one, and I mean a very good one. I say it's a challenging one. Every once in a while, all of us needs a little challenge problem. And there's no exceptions. When you're taking calculus, you got to see those challenge problems. Okay, here it is. This is example 4. Alright, D. Alright. Oh yeah. Let me go back to my other example. I just had an aha thing here. Yes. I actually copied the problem incorrectly, but this is the right way. Let me do two more examples then, okay? I'm going to show you a little idea here. Okay. If we have, let's put this again, if the variable is on the bottom, it can't be there. And let's go with still tangent t dt. We cannot do this as is. There is a rule that if you have x a over, I mean a is a number, x is a variable, alpha t dt, then you've got to flip it over, but you put a negative sign in front, and then that flips this, we might say integrand over, okay, from x to a to x. Now it's looking right, but you got to put a negative sign in front. Now that is correct here. Okay, and the only thing about it is your answer is negative. Alright, alpha at x, negative alpha at x. So we're going to apply the same principle here, and I just happened to see that from the last example. I forgot to turn that over, but you can readily see what the answer is. Okay. Alright, let me erase this, and I'm going to erase the whole thing when we get ready to do the last problem, because it's going to take this whole entire board, probably. Now, what do we do? Well, let's rewrite the problem. And we could put the negative right here, does not matter, times the negative. Now if you want to do it like that, I like to separate that sometimes, it just looks better to me. Tangent t dt. Now we know, but we still got to keep the negative sign, but it's tangent of x cubed. Now the derivative of x cubed is 3x squared. We've already done that part. Alright, and then now negative 3x squared tangent x cubed. That's it. I like that. We got to know that basic rule there, don't we? There are other rules that we need to look at, but this is one of them that really stick out when you're trying to do these types of problems. That comes up pretty often, and there's no exception to this last one. Alright, let's do that. I want to say, let's keep that up there. Okay, what do you say we do this one? It's a good one. Like I said, it's a very good one. Oh my. Here we go. Okay, here we go. Sine squared of 7x 2 t squared. You're already looking at this thing. KP the map G, what are you doing? What are you doing to us? Well, I'm helping you see that sometimes you're going to have a challenging problem like this. And you already know that you got to flip it because there's an x. The x is on the bottom. We want that on top. So let's get a different color. I want this to be Alright, negative, yeah, sine squared 7x to 0. Wow, this is before you say, I can't do this, yes, you can. Yes, you can. What is this? You're going to keep your negative. You're going to plug this whole thing in here. Right? Let's do that. So this is equal to negative 2. I might as well just put the negative with the 2. Just bring in the negative with the 2. 1 plus something squared. Now I need a little wider parentheses. And I'm definitely going to take the derivative of this something here. Matter of fact, I'm going to show you. It's going to be that right there. I'm going to take the derivative of that right there. So I'm just going to put this in here. Sine squared 7x. You cannot just leave it right here and not consider this derivative here. You just can't do that. Alright? I can do something with this. This just actually means all this is squared but still raised to the second. And I know that that's actually a 4 there. But a lot of the numbers are put right here. So we're going to leave it there like that. After all, this is calculus or AP calculus. Alright. So now this is negative 2 over 1 plus sine to the 4th 7x. 2 times 2 is 4. Now I want to do the derivative of sine squared. Whoa. How do we do that? Anybody think of something? If you said chain rule, give yourself a pat on the back. Yeah, absolutely. So right here, times 2. Now remember, we work from the outside in. We're not taking the derivative of sine. Remember, this is reduced by 1. Oh, yeah. Times. Now, what derivative do we take? Yeah, not 7x yet, but sine. Ooh, we got to remember that. Derivative of sine is cosine. Now the derivative of 7x, which is just 7. Now this, except for the 7 on the end, this is an identity. Sometimes when I was doing this, I would not recognize the identity. But now as you move along, this is an identity. Remember this identity here, what this is? 2 sine A cosine A. Remember what that identity is? Yeah, it's been a while, hasn't it, since we've taken trigonometry and seen all those identities? Well, it's just sine 2a. Now, since this is 7x, then we can say that 2, let's do this, 7x cosine 7x is 2 times sine 2 7x. Now, I can multiply these two together. They are all together, so this is equal to sine 14x. Right there. So all this, 2 sine A cosine A is cosine 14x. Alright, so I've got 7 times negative 2. Negative 2 times 7 is negative 14. So let's see, let's put it up here. I'm going to have to remember, okay, all of this is equal to this part right here is equal to sine 14, sine 14x. Okay, all of that. Okay. Alright, I'm going to erase this so I can put my final answer up here. I knew I'd need all this space. Okay, now this is equal to, alright, now this is 7 times negative 2, which is negative 14 on top. Negative 14 sine 14x all over 1 plus sine raised to the 4th 7x. Wow. I told you that would be quite a chunk, right? So really, I mean, even if you left it like this, at least you had the idea, right? If you didn't know to change this to sine 14x, at least you knew how to get down to this. But anytime you see a 2 sine A cosine A, you can multiply these two together and make this sine 14x. Remember, that's equal to sine of 2a. Okay, so all of that, this is it right here. Whew. Alright, that's what I'm talking about here. This is a really wonderful, good problem. So let's go back and review real quickly. Alright, sometimes you can just, it's just sine, but then cosine, you just plug the x in. Derivative of x is 1. Here we've plugged the 3 in. Derivative of x cubed is 3x squared. Here was just a little bit more to it. We had to take the derivative of what's inside there. Inside of this, t. And we squared it right here. Okay, t squared. T is sine squared 7x. I plugged that in there. Okay. Squaring it gives me a exponent of 4 right there. I'm only squaring this part right here. Then, once I take the derivative of this, okay, now not with the 4, just here. You're not doing the 4 here, you're doing the 2 right here. You're doing this. Taking this derivative. Don't do this and then say, oh, I'm going to take the derivative of this. No, you're not. You're taking the derivative of this, which is right up here. That's what you're taking the derivative of. Always look back to see what you need to take the derivative of. Alright, now, again, 2 sine A. I need to take the derivative of sine, which is cosine A, and then take the derivative of this, which is 7. 7 times negative 2 is negative 14. This is cosine or sine 14x, and then just recopy this 1 plus sine raised to the 4th 7x. And that's it. This is probably the most difficult one you will see. and it would be just one problem probably out of the whole entire test, but still, this is probably a good multiple choice question is probably what it is. Okay, most likely. Alright, anyway, this is KP the Math G. I do appreciate everyone who has been tuning in, or who, if you just now started tuning in, I do appreciate you. Please, if you will, if you want to, please hit the subscribe button. And if you want to make a comment, please make a comment. Well done, KP, the Math G. Or just say, hey, I know of a better way. But again, if you show me a better way, you had better be right about that. And if you're right, I guarantee you, I will come back and do what you showed me. A better way. Because that's what I am. That's who I am. I'm KP the Math G, and I always want to present the best way of doing something. Okay, the next video then is going to be on the second fundamental theorem of the calculus, and we will do some examples from that and actually go from there. Again, KP the Math G signing off. All of you have a great, great day.